Hi there. This is a video we're making for the Living Computer Museum. We repackaged an SC40 Systems Concepts, Systems Group, SC Group, SC40 computer into a single lowboy deck cabinet. And we have it as fully operational as we can get it. I'm going to take you through how to start it up. At least you get a reference point. You'll get a working PDP10 operating system, the one that CompuServe used in production on the CompuServe network. It is a derivative of TOPS 10. Anyhow, I'm Jerry, and you at the museum know how to contact me. We have a twin HAL 9000 we built here for ourselves. Both seem to operate very similarly. But this is the one we're going to send you guys. First of all, to bring it up, you'll need a PC and a cable. We're going to include the cable inside the box here. PC just is acting like a VT100 terminal at 9600 baud. We're using a program called TerraTerm. If you use TerraTerm, fire it up, just click the serial button, hit okie dokie, and the defaults in TerraTerm are correct for this computer. This is a straight RS-232 cable, and it's plugged into a 9-pin COM1 adapter on the back of the PC. Turns out to be 9600 baud, 819, all that normal async default stuff. So, let me show you the machine. It's a deck lowboy. We did a nice job of routing the cables. We've marked everything. The cable which we'll leave in the machine goes on port 0. We can only make async port 0 work. Really haven't gotten into finding out why any of that works or doesn't work. But you guys are smarter than us, so you can knock that out. There are two styles of SC40 processor. We'll be sending you 4 more spares in 2 large relay racks. 3 of them are old school, different packaging. This one is new school, nicer packaging. We marked the SCSI stuff. This machine uses SCSI I/O. The DZA string, the first disk string which you need to boot, is connected to a shelf that CompuServe manufactured. We've connected only unit 0 to an LED, so when you bring this up you'll see that guy flash, you won't see any others flash. This is the DZB string. How successful you'll be with that, we're not sure. It may need formatting, refreshed, or who knows what. There is also a mag tape unit, dual drive on here. It is a DAT style mag tape unit. One comes up, the other one seems intermittent, and this is the controller for it. And you can come up without this. If you do, operating system will ask you a question, do you want to proceed without mag tape? Say yes. We don't even have any media for this tape drive, so we have no idea. But they seem to do, this drive here seems to do exactly the right things. We have the exact same system on our machine. So these are the SCSIs, the mag tape, more SCSI ports unused. This is the FDDI, copper FDDI ports. We didn't play with those at all. And this is a part of the SCSI bus for the supervisor. The processor in here has a supervisor card, and it loads all of the microcode for the PDP10 processor chips and also the SCSI interfaces. It seems like every one of these cards has some microcode in it. It also has its own SCSI disk drive on the back that is directly connected to the support processor. And there's a bit of trivia here. They call the support processor the MSC for the Mars system controller, because DEC's project to build the biggest PDP-10 was called the Jupiter Project. And they went to a DECA show with this box and said, well, Jupiter is great, but Mars is closer. So there's a piece of trivia and humor. Let's see, it covered that. So this plus 2 more high bays with 4 more processors plus a box of spares plus this. Everything we know about the SC40 processor. There's information about microcode revs here, etc., etc. Completely confusing, and good luck. The first section in this shows you booting up an SC40, and I'm going to do that in a minute. Underlined are the commands you type to get the monitor to come up. What else? I'll take you around through the machine a little hardware-wise, so you have a knowledge transfer of everything we know. We added a switch to turn on the power AC power distribution panel. It's a stock DEC type distribution panel. We made this the remote on and off for the whole system. I would bring the system up not with the processor on, but the processor has a separate power switch, leave it off. Inside of these here bays, slide outs, these are SCSI disc strings. The tops just come off. Everything is heavy as hell, made pretty ruggedly. They have load sharing power supplies to provide the 12 volts and 5 needed by these standard kind of SCSI disk drives. These are small, 4.5 megabytes. And from what we can tell, the monitor is on unit 0, and if it won't come up, you won't come up, but it doesn't necessarily need these others. We went through the drives, checked them out, and got this string of 1, 2, 3, 4, 5 of them. There's an old school one, he's big, to work and come up online. In the DZB string, we've got one of them to come up online. And at any rate, so I'll close this up. And all these controls on the front for SCSI ID, they're modern art. There were some previous rev drive was connected to them. They're all jumpered with 10 center jumper headers to select the SCSI IDs, and they're marked on them which one. 0 has the only one that has an LED on it. Don't pinch the cable. Okay, so if we go around the back here, you will see there's a standard DEC distribution panel. We made a Hubble to regular 3-prong adapter. The Hubble is a 20 amp twist lock for 110, but this is 110 volts, and it doesn't draw more than, I don't know, maybe 3,000 watts. So you can hook it up that way right away to a wall outlet. In the back, from the top, these are the 2 DAT tape drives, and that's the controller. They have retainer screws on the back and the drives on the front to keep them from sliding out. Hopefully they won't do that until they arrive. This is the SC40 processor, the backplane side. You open these terminals, these captive screws, and there you go. In here you will see this is the system control processor. This is the processor itself, the PDP10 Systems Concepts version of a PDP10 processor. It has some closely coupled memory sims. These are 2 32 megaword memory banks, and they can be populated with more memory. We haven't tried that. There's more memory in the backup machines we're sending you. There's a couple of 1 or 2 bus control, and these are the SCSI interfaces. And one of these is I think this one is the FDDI controller. when you turn these machines on, these are the power supplies. They got a twist lock, and you can swap them out like that. We'll send you some spares. You will get on a lot of these machines an airflow fault. Don't worry about it. The fans are running. There's a sensor in there somewhere that's gummed up, and we didn't mess with that. So don't worry about just an airflow fault. You'll see them draw maybe 10 amps apiece. That's the 5-volt rail. Okay. So SCSI cables come out from the ports on the front. They go to each DZA and DZB string, and the terminator is like there. We didn't clip those on there. Shoddy work. So there we go. And they got AC power cords. All the AC line cords are connected into that distribution panel. And that's the main line cord. And we're going to throw it on and do some stuff now. To bring the system up, make sure you got your Terraterm 9600 baud working, and throw the main power switch. And you'll see SCSI 0 light will come on this bay while the drive gets reset and happy things happen. You'll also see the mag tape say Unit 1. If you don't want to power them up, this has an on-off switch. Garbled LCD words will come out of here because the LCD is old, but basically it passes self-test. I wait for the SCSIs to spin up. You do have the same problem with the SCSI that's integrated into the SC40 processor. It is behind a door in the back on the top. It connects directly into the SCSI cable on the back plane. To turn the machine on, do that. And you should see the state light flash, and you will get messages. These are from the system control processor boot ROM, and it whines about Unit 0 having a home block read error, but I think that's just as the drive is spinning up. It finally spins up properly, and then you should see it load the CPU microcode. It will announce a version of the SC40 supervisor program, and then it will start loading microcode for each of the SCSI channels. And like that. And you'll get an NSP prompt. Then you'll want to just look at the document marked booting an SC40 host. I'm really not certain that all of this gibberish you have to type is required, but this is a cookbook way to make sure it comes up. The ultimate answer is to really get a standard TOPS 10 monitor compiled and loaded on SCSI 0 drive and get it to work. I haven't figured out how to do that. There's not enough time here to play with that. Any rate, so we type take PINI 40, something in it 40. And it says command completed. Then we say select channel 1 for some reason, and then we say load M, which seems to select the channel SCSI controller, and load microcode, which it seems to have already done. Then we say select CPU 0. I'm not sure why, because it seems like it's a uniprocessor. Then we say assign channel 1, CHAN 1 to 1. And then this is the program that boots up the monitor. From what I can tell, it's a program on the local support processor. Goes out probably, I'm assuming, in 1,2 on DSKA string. Or, right, DZA string. And looks for the monitor and runs it. And you say run boot 40. So it will say some things here, clearing memory, Then it will go through each of the SCSI and weird controllers, and if it fails here, there's something in the disk string wrong. And then it says BTS. That is some intermediate. I think that this is the boot program giving you another prompt. You haven't run the monitor at this point, but what you do is simply hit return, and then you should see CompuServe KHH299. That's their build of the monitor with the build date. Their version of the PDP10 monitor tells you when it was compiled or assembled. And why reload? Just hit return. It will say something snappy. You should give a reason. Code, hit return, and it will start to bring up all the baseline monitor jobs, including OpServe, OpCon, or Op something. It will also echo out the disks it sees on DZA, the mag tape units, and yeah, it's not showing any DZB disks. So there's some work to do there, but apparently it will boot with just one unit, unit 0 of the DZA string. It IDs the Seagate ID, serial numbers, da-da. It also tells us the mag tape's up and running with 2 units on it, and it will say at some point there are no network links. The network links were done through the FDDI controller, and that's black magic. So tell it to proceed anyway. For operator ID, you can type in anything, and then it will ask for the time and date. It may ask for it in different ways depending upon how long it is since you last reloaded it. It seems to have some clock information in it. So it is 4-March, and then a colon with the hour, which is 12, 13, 13. Let's call it 1400. Oops, no colon. It will say, are you sure it's Wednesday? Yes. Oh, I've given it the wrong date. Oh, it's okay. Yes, we think it's a good time. Sure, the time is that. Then it asks for an operator ID again. You can type that. And STR-SAJ is a program that starts all the monitor auto start jobs, all of which running detached in background or detached. And a ton of error messages will come up about the network, about billing not being there. CompuServe was interested in billing. We are not. And eventually it will come up and show you the jobs that are running. And if we type dir sys : you will get a list of tons of files on the system structure, and some of which are obviously needed, some of which are obviously there for CompuServe. CompuServe had a way too to move the users around from computer to computer. When you dialed in, apparently it tried to attach you to the PDP10 that you were resident in. But if that didn't happen, it would actually move your files over to another structure attached to the PDP10 that you did get logged into through the FDDI ring. So, that's about it. It's not stuck. Those are all the files on there. There you go. There are 197 million characters of storage and 1,001 files. How about that? A lot of these have dates. Here's one date of 77, 78, 82, 83, 98. So almost to the year 2000, they were still improving the software on this computer. I wish you good luck with the machine. It will also continue to gibber out messages to the operator that the WAN links are down, that ARP is failing for gateways, that, you know, the mag tapes aren't ready to do backup. And one other note is apparently the 4 terminal controllers it has, which are probably the easiest way to get it on the network, are supported as they look like a DC10 async terminal scanner. It was the DC10. It used to be a huge box all by itself, relay rack full of lights, and it supported like 8 or 16 terminals, usually teletypes. They should be supported by some version of the monitor and some version of microcode, since it looks like a DC10. I'm assuming too that these SCSI controllers through the microcode look like some stock RPO whatever disk drive on mass bus or on ancient DEC bus, PDP10 bus. I have not figured out how to shut it down, but turning the power switch off doesn't screw up anything, and then killing the power after that to the whole bag. We're going to pack it up, weigh it, put it on pallets, shrink wrap it, and I expect a free entrance to the museum anytime I want. Thank you very much, and good luck with the machine. Don't put it in the dumpster. Thanks.